So, with all the incredible advancements in AI, there's a huge question hanging in the air. Is learning to code basically pointless now? Is this skill that we've been told is the key to the future about to become a relic of the past?
All right, let's just dive right in. This is the quote that set the tech world on fire. It's from Jensen Huang, the CEO of NVIDIA, the company that is literally building the engine for this entire AI revolution. When he said this, it kicked off a massive debate. So what on earth did he mean?
Well, the core idea here is pretty radical. It's the argument that the barrier between us and computers is just vanishing. For decades, right, we've needed to learn these really complex, specialized languages to tell computers what to do. But the new thinking is that the next big programming language is, well, it's just human language, the way you and I are talking right now. What Wang and so many others are really getting at is the rise of a brand new skill, prompt engineering. It's all about your ability to clearly and cleverly tell an AI exactly what you want it to do. The idea is that technology is getting so smart, you won't need to write lines of Python anymore. You'll just need to describe the result you want in plain English.
And look, this isn't some far-off theory. It is happening right now. We're seeing people with literally zero coding background building real, working AI applications. And then you have Devin, the first AI software engineer that can pass job interviews and get paid for actual work. I mean, the proof is starting to pile up. But, hold on, that's only one side of the coin. Because there's a really powerful counterargument that says, in the age of AI, the foundations of programming are actually more important than they have ever been.
Let's just get back to basics for a second. What even is programming? At its heart, it's about giving a machine instructions that are totally specific, precise, and have zero ambiguity. Computers don't really get kinda or sorta. You can't just tell a computer, go in the house. You have to spell it out. Walk to the door, raise your hand, turn the knob, push the door open, step inside. That level of precision is the soul of programming. And this really gets to the core of it. AI might be able to spit out the code, the actual syntax of a language, but it can't, on its own, come up with the underlying logic. The human brain is still the one that has to structure the solution and design that step-by-step process to solve a really tough problem. And these skills, they are the absolute bedrock. Understanding how algorithms really work, how to structure a database so it's efficient, how to design the logic for an entire system, these skills are timeless. The AI is just a tool that helps you do it faster. It's not a replacement for the knowledge itself. So how do we make sense of these two arguments? They both sound right, don't they? Well, the answer is in seeing how the role itself is changing. We're witnessing a major shift from being a coder to being a developer, or maybe even something more, like a digital architect.
This little chart just nails the whole shift. A coder is focused on the what, just writing the lines of code. But a developer, they're focused on the how and the why. They design the entire system, the architecture, and they solve the big, messy problems. AI is getting amazing at the tasks on the left, which only makes the human skills on the right that much more valuable.
To put it simply, AI is a massive force multiplier. It handles all the boring, repetitive stuff, which frees up the human to focus on the big picture, the high-level architecture, creative solutions, and the overall vision for a project.
And hey, the data completely backs this up. Just look at the insane growth of Python. Why do you think it's the most popular language on the planet right now? It's because it's the language of AI. Programming isn't dying, it's just moving to where the action is, to where the most powerful new tools are being built.
So, what does this all look like in the real world? Well, it's leading us straight to the next big thing: AI agents that can act for us, controlled simply by us talking to them. Yeah, the next big leap isn't just about using AI to help us write software. It's about using AI to operate the software we already have. Just imagine telling your computer, in plain language, hey, find the sales numbers from last quarter, put them in a chart, and email it to the team. And an AI agent just does it. The key piece of tech that's making this possible is a new standard called MCP, which stands for Model Context Protocol. The easiest way to think about it is like a universal language that lets AIs like Claude or ChatGPT talk to and control all your other apps, your calendar, your design software, you name it. So here's how it works. You give a command like, create a file that shows the sum of 8 and 9. The LLM figures out what you want, uses MCP to call a file creator tool, that tool does the work, and boom, it's done.
It's a completely seamless bridge from your thought to a machine's action.
Honestly, the best metaphor for this is a universal remote. You just speak, and MCP translates what you said into actions that any app that understands the protocol can carry out. This is a huge step toward making all of our software truly conversational.
So let's bring this all home. What does this all mean for anyone who builds things with technology, today and tomorrow? It means we're seeing the rise of a new kind of role, the digital architect.
The whole hierarchy of skills is flipping. It's not going to be about how many programming languages you can list on your resume. Your real value, your superpower, is going to be your ability to see the big picture, to design, to architect, and to manage complex systems, using AI as your #1 tool. So this is the new toolkit. This is what you need to focus on. We're talking about system design, high-level problem solving, and knowing exactly how to use AI to get the job done. It's about combining that with deep knowledge in your specific field and planning for things like security and maintenance.
In a way, Jensen Huang was both right and wrong. Maybe you don't need to learn to code in that old-school sense of just typing out lines, but you absolutely have to learn to think like a programmer, how to solve problems logically, step by step. The question isn't, should you learn anymore? The real question for the future is, what kind of architect are you going to be?